Okay, so hello guys. My name is Nishant Kumar, and I am a fourth year student of IIT Mandi from mechanical branch. So today I will explain how to solve a flow problem using OpenFoam. We will study the flow of air passed in a thin rectangular plate, which is at a 45-degree angle to the flow. Okay, so first of all, I want to explain about the rough diagram of flow, which you can see here. This. Okay, so basically this is a rough diagram of flow around the thin rectangular plate placed at a 45-degree angle of the airflow. Let me explain each part step by step. So first I want to discuss about inlet. Okay, so on the left side we see the inlet. This is where the air enters the domain. The flow moves from left to right. Okay, so now outlet. On the right side, this arrow. Okay, uh, we have the outlet here. Here the flow exists the domain smoothly. Okay, so also this is top and bottom plate, and this is the in center. There is a thin plate oriented at 45-degree to flow, and this is the top and bottom boundaries. These boundaries are either symmetric condition or allowed to float the slide smoothly. Okay, additionally, you can see here there is some eddies created. Okay, so you can see that the wake behind the plate shown the eddies rotating flow pattern. This happens because the plate blocks the flow and creates low pressure region. This behavior affects the lift and drag forces on the plate, which we will analyze later. Okay, so now I am going on assumptions. So here are assumptions. So I wrote here first incompressible flow, where we know that in incompressible flow rho is constant. So we can say d rho by dt, or also we can say d rho by dx is equal to 0. Okay. Second in 2g transient flow. So fluid flow only in x direction and y direction, not in z direction. Okay, so third is neglecting gravity effect like gx, gy, and gz. The three all term is zero. Okay. Uh, Fourthly, velocity of inlet u is equal to 1 meter per second and v is equal to 0. Lastly, neglecting external force. So we can say there is no any external force in this system. Oh, so now I am coming to governing equation. So first, continuity equation. So we know that the continuity equation is expressed by d rho by dt plus del dot rho u vector is equal to 0, where rho is equal to constant because we know that when the fluid is incompressible, or also we can say flow is incompressible, where rho is constant. Therefore, d rho by dt is equal to 0. And also, we know that no any movement in direction. Therefore, we can say del z by del omega y del w by del z is equal to 0 because w is 0. So we got the final equation del dot u, and This is the final equation. Del u by del x plus del v by del y is equal to 0. This is the equation A. Okay. If I talking about momentum equation, so we know that momentum equation is also called Navier-Stokes equation, and this is expressed by del u by del t plus u del u by del x plus v del u by del y plus w del u by del z is equal to gx minus 1 by rho plus del p by del x plus nu del square u. Okay. So if I apply the boundary condition in this equation, so then we know gx is equal to 0. So there is no effect of gravity in x direction. We are also assumed in above slide, and also we know w is equal to 0. So finally we got the equation. So therefore these three terms become 0. Okay. So finally we got del u by del t plus u del u by del x plus v del u by del y. Oh, sorry. This is some error. So I am right in right way. So this is del u by del y. Sorry for this. Okay. Del u by del y is equal to minus 1 by rho del p by del x plus mu del square u upon del x square plus del square u upon del y square. So this is the equation number B. Okay. Okay. And now similar we can write in y direction. So this is the general expression in y direction del v by del t plus u del v by del x plus b del v by del y plus w del v by del z is equal to gy minus 1 by rho del p by del y plus nu del square v upon del x square plus del square v upon del y square plus del square v upon del z square. If I apply the boundary condition in this equation, so there is no effect of gravity in y direction. Therefore, we can say gy is equal to 0, and and also we know uh, in z direction there is no movement of fluid. Therefore, w is equal to 0. So finally, we got the momentum equation in y direction del v by del t plus u del v by del x plus v del v by del y is equal to minus 1 by rho del v by del y plus nu del square v upon del x square plus del square v upon del y square. This is the equation C. Okay. So now if I discuss about boundary conditions, so you can see here this is a plate which is oriented from horizontally at 45 degree. This is outline, this is inlet. Okay, so fine. Now I'm focusing on the boundary conditions. So first for wall geometry. If I talking about the wall geometry, therefore top, bottom, and rectangular plate. This is the type wall. Okay, okay. So and second is the front and back wall. This is the type empty. And the lastly the inlet and outlet. This is the type patch. Okay. So this is the boundary condition for pressure, and also you can say in the pressure form. So this is the front and back. There we can say this is the type empty. For outlet, this is the type fixed value, and this is the fixed value is 0. Okay. For inlet, type 0 gradient, and for the bottom, top, and rectangular shape, type 0 gradient. Okay. So lastly, body condition for velocity. So first for front and back wall type empty, because you know there is no movement of fluid in this direction, and also you can say in z direction. For top and bottom and rectangular shape there is type no slip boundary condition. As you I think you read in heat transfer, there we can say there is some boundary layer formed, and this is the boundary layer, and near the plate the velocity of fluid and the velocity of plate, we can assume 0. Therefore, we can say this is the no slip boundary condition. Got it? Okay. So, the third condition for outlet type 0 gradient. And so we can say the fluid become fully developed flow. And the condition of fully developed flow, we can say del u by del x is equal to 0. Okay. For lastly, for inlet. So type fixed value, and the value is uniform, and that is 100, and this is 100 we are assumed before, uh, like ux is equal to 1 meter per second, v, yeah, also you can say uy is equal to 0 and uz is equal to 0. Therefore, it's make a row matrix, and this is 100. Okay, so now we are going to open for and simulate this. Okay, okay.